Hey everyone, welcome to lesson 1.2, solving linear inequalities. Our goal here is going to be able to solve them and then represent the solutions on a number line in interval notation. Inequality notation is also here, but you're mostly going to start with that. I also have all of the symbols over here. You've probably seen them before. These two that have the pointy end on the left side are less than, okay? Left is less than, and they end up shading to the left. To the right is greater than, and they shade to the right. Left less than, right greater than. And then the last thing we're going to say is that if there's this little bar, it means or equals to. The or equals to means you're going to have solid dots. And the not or equals to means you're going to have open circles. Okay, so again, you've probably heard of that before. And what I'm going to do is kind of just walk you through some simple examples that are already solved, and then we'll talk about how to solve them and then put them on the graph. So first things first, ignore the yellow. I put negative infinity and positive infinity on each side because these numbers go off to negative infinity and these go off to positive infinity. This number line doesn't end where it shows on the page. It keeps going forever in both directions. Okay? So we're going to start with interval notation. Interval notation pretty much asks you to describe how far left then right the graph goes, because we read left to right. So you kind of say, hey, here's where it starts on the left, here's where it ends on the right. So on the left side, it starts at 3. And see how that's an open circle? Open circles are going to get parentheses. So that's going to become parentheses 3. Then it goes to the right all the way to positive infinity. So I'm going to put positive infinity with a parentheses. Okay? And what I'm going to do is make you a little note up here that says parentheses are going to go with open circles or infinities. Okay, what I mean by infinities, not just one, is negative or positive both get the parentheses. Then we're going to use brackets that look like this only for closed circles. Okay? Then I'm going to come over here and do the inequality notation. So what are we saying about x, which is represented by the line? Well, it starts at 3 and goes up. So we could say that x is greater than 3, which is this symbol. So I'm going to put x, that symbol, and then 3. Notice how I didn't add the equals to, because if it was or equals to, then it would be a solid circle like this. And it's not this one, it's this one. So no bar. Okay, no bar, and to the right is just greater than. Right, open circle, boom. Okay? Now, let's say we started with interval notation. This says negative infinity, comma, 2. That means we're going to start on the negative infinity side, which is over here, and go all the way up until we get to 2. So, I'm starting at negative infinity, I'm going all the way up until I get to 2. And then I'm going to put a solid circle there because it's got a bracket. And we use brackets with closed circles. Okay? Then I'm going to come over here, and we're saying that x is going to the left of 2. So it's less than. Less than in a closed circle is less than or equal to. So I get to put this symbol right here. Okay? Realize that all 3 of these are saying the same thing. Then we're going to get a little bit more difficult. This one is saying negative 1 is less than x is less than negative 4, or equal to negative 4. This is really just a fancy way of saying that x is between negative 1 and 4. But the negative 1 is going to get an open circle because it doesn't have the little bar underneath. The 4 is going to get a solid circle because it does. And then for interval notation, this one doesn't go to either infinities because it doesn't keep going out here. It's just -1, comma, 4, because those are the two ends of your graph. -1 on the left gets a parentheses because it's an open circle. The 4 is closed, so it gets brackets, or a bracket. Okay, so see, it can be mixed and matched. It just only gets a parentheses with the number if it was an open circle, like the 3 and the -1. Okay, and then at the very end, it says x is less than or equal to 2 or greater than 5. So for the less than or equal to 2, we're going to start at 2 and go to the left. Kind of like we did on this one. It's the exact same start. Okay, so then we go from -infinity on the left all the way up to 2. And the 2 gets a bracket because it's a closed circle. Then we add in the x is greater than 5. So we're going to start at 5 and go to the right because it's greater. And it gets an open circle because there's no bar. Which means that on the inequality notation, it gets a parentheses. And it goes off to infinity. Okay, and again, I'm going to write the -infinity and positive infinity again. Just so you know, negative is always on the left, positive is always on the right. And let's go ahead and make a note down here that inequality notation is left, comma, right. So you just have to look at how far left, then how far right. Okay, and if you have a little gap right here, what you do on the interval notation is you write a little u. Okay, I'm not really going to count off for that, but you write both of them with a little u in between. Alright, let's start solving. You guys aren't going to have to do it quite like that every single time. Most of the time it's going to start with the notation like this. And we're going to solve it kind of like an equation. So for example, over here, we want to get rid of that 17. Since it's positive, we need to subtract it. (29 minus 17 is 12. Then, just like we would on an equation, we're going to divide by 3. But notice how I'm keeping the same symbol in between. The only time when that symbol needs to change is if you multiply by a negative number, you must flip the symbol. This also works for division too. So I'm going to put /divide. Okay, so if you multiply or divide by a negative, you have to flip it. Otherwise, you don't change anything. Now, this is pointing to the right, so that's greater. X is greater than 4. So we're just going to put 4. I'm going to put 3, 4, 5 on my number line. I'm going to put an open circle because there's no equals to bar. And it's going to go to the right because it's greater. And the pointy end is on the right. Then for my interval notation, always do the graph first because now I can see that the left side of this graph is at 4 and the right side goes to positive infinity. So I'm going to put 4, comma, positive infinity, and there's no closed circles here, so both sides get a parentheses. Okay, over here, you should know that you have to multiply this 2 first, because that's distribution. Okay. Boom. Then, I need to add together my x's. 3x minus 4x is negative 1x. Then I'm going to subtract the 10, just like I would if it was an equation. Nothing is changing about my symbol yet. 15 minus 10 is 5. Now, watch out, because we need to divide by -1. Whenever you divide by a negative, that symbol flips the other direction. Okay, so we divided by -1, which means it has to flip. And 5 divided by -1 is -5. Okay. Now, this is on the left side now, which is less than. So this says x is less than or equal to -5. So I'm going to go -6, -5, -4, -3. Okay. I'm going to put an open circle, or closed circle, sorry, because it does have the equals to, at -5. And since it's less than, I'm going to go to the left. And then for my interval notation, it starts on the left at -infinity, comma. To the right, it keeps going until it gets to -5. And then the -5 gets a bracket, or a square parentheses, because it's got a closed circle. And then last but not least, this third one over here has a fraction. And how do we get rid of fractions? By multiplying. In this case, you don't need to find a least common denominator because there's only one denominator, 3. So I'm going to multiply by 3 so there's no fractions left. Okay, 3 times 4 is 12. 3 times 14 is 42. 3 times 2/3 is 2. And 3 times 7 is 21. Now I need to get my 42 to move sides, so I'm going to subtract it. (21 minus 42 is -21. And then I'm going to subtract my x's. (10x) is less than or equal to -21. Divide by 10. Neat trick when you divide by 10. Just move the decimal point back 1. So instead of 21, it's going to be 2.1. Now, there's a negative here, but the number I was dividing by was 10. That's not negative, so this does not need to be flipped. Okay, and I'm just going to put 1, 2, 3, 4. Gosh darn it, guys, I forgot my negatives. So let's just go with -3, -2, -1, 0. Sorry about that. -2.1 is going to be like right here. And it gets an open circle because there's an or equals to bar. This is pointing to the left, so that's a less than. So my interval notation is going to go from -infinity on the left, comma, the right side ends at -2.1. And then the -2.1 gets a square bracket because it is an or equals to. You don't ever have to ask yourself about the infinities because they always get parentheses.